go over this first quiz for Chapter 3. Students took this the other day. I'm now grading these out of 10 instead of 4, so I'm actually not going to count the first chapter's worth of quizzes. I don't think 4 was a good guideline for student knowledge. And to be honest, grading these a little bit is kind of a gut thing as well, seeing what students know. But what I would like to see is I'd like to see students see that this too applies, kind of like distributive property, but it's really not. So this becomes then 4 squared times y cubed squared, which is then simplified into 16 y to the 6th. When we raise an exponent to an exponent, we multiply those. And why that is simple. If I write x squared, I can write that as x times x. And so I can rewrite this. And this is for those that might be struggling with why this works. I've got 4y cubed times 4y cubed. Now, this is all multiplication. The 4 is multiplying the 3y's here, and this 4 is multiplying 3y's here. So I can rewrite that as 4 times y times y times y times 4 times y times y times y. And order of operations doesn't really come into play much here, because when it's all multiplying, math doesn't care what order you do that in. So I can rewrite that again as 4 times 4 times y times y times y times y times y times y. And what I see now is that I've got 16 y to the 6th, because I have 6 y's expressed in this when I expand it out. So how we get to this answer is less concerning to me than that we can get to it, whether you're expanding it out or whether you're applying the rules. And this one can work the same way, but the numbers are so big that it would be really difficult to draw this all out, because you'd have 9k's expressed 5 times and 3k's expressed 2 times. So if I have 9k's 5 times, I can multiply these guys, and I get k to the 9 times 5 times k, because that's times in there, to the 3 times 2, so I've got 45k's times 6 k to the 6th power Now, how many k's total do I have multiplying one another? Well, there's 45 here and there's 6 there, so that becomes k to the 45 plus 6, or k to the 51st power. So breaking it apart like this is certainly possible here, but it would be, I don't think there would be enough paper for it. So anyway, understanding these rules, where when we raise a power to a power, we multiply, and then when we're taking like bases with different exponents, or even they could be the same exponent, you add the exponents. Those are our rules that we're learning right now, and some are struggling with a little bit.